Arithmetic progression. Now we already know what is an arithmetic progression. Now let us see what are the terms in AP. For that, let me consider one AP. That means let me consider one arithmetic progression. So here is an example. 2, 5, 8, 11, 14, 17, 20. First of all, let us identify whether this sequence is an AP or not. So quite obviously, to check whether it is an AP or not, we will just see whether the difference between two consecutive terms is constant or not. What is the difference between 5 and 2? The difference between 5 and 2 is 3. What is the difference between 8 and 5? 8 minus 5, again 3. 11 minus 8 is again 3. 14 minus 11 is 3. 17 minus 14 is 3. And 20 minus 17 is 3. So quite obviously the difference between any two consecutive terms over here is 3. So yes, this sequence is an AP. Now let us see the terms related to AP. The first term of an AP is denoted by A1 or A. So we have this sequence 2, 5, 8, 11, 14, 17, 20. This is definitely an AP. The first term of an AP is denoted by A1 or A. So the first term, very first term over here is 2, and this term is denoted by A1 or A. So we can say that here A is 2. You can also say A1 is 2. Similarly, the second term is denoted by A2, third term is denoted by A3, fourth term is denoted by A4, and so on. So if I want to just find out which is the second term, third term, and fourth term, it is very easy to identify. The first term A is 2 because A is the first term, and we can clearly see here A or A1, both of them stand for first term. Then the second term A2 is the second term. The second term used over here is 5. So clearly we can say A2 is equal to 5. What will be the third term? A3. A3 will be the third term. So I can say that A3 is equal to 8. A4, if I want to find out A4, A4 is 11. 14 will be A5. 17 will be A6. 20 will be A7. Now what will be A8? Can you guess what will be A8? It is very simple, as we know that here the difference between any two consecutive terms is 3. We can just add up 3 in this case, and we can easily get our 8th term, which will be 23. Then again, if I want to find out the 9th term, you can clearly see plus 3, you'll get 26, and so on. Now we know that since it is an AP and difference between two consecutive terms is constant, as I have already mentioned, this difference is called as the common difference, and the common difference is denoted by D. Now we know that the common difference in this case is 3. Whenever I add 3, I get the succeeding number. So 3 is the common difference and it is denoted by D. And note that it is small d. So I can say that the value of D is 3. The value of D is 3. Now we have a formula to calculate the value of D. The value of D is given by A2 minus A1. Quite clearly A2 minus A1. You can see how. So D is given by always A2 minus A1. A2 is 5 and A1 is 2. So I can say 5 minus 2. And 5 minus 2 will ultimately give me 3. So I can easily find out the value of D just by using the formula A2 minus A1. Suppose if I have one more AP, say like this, say 2, 7, 12, 17, 22, and so on. I can easily find out all the values. The value of A, or I can say the value of A1 will be equal to 2. So this is our A or A1. Similarly, if I want to find out A2, A2 is the second term. A2 will be 7. And suppose if I want to find out the value of D, I'll just apply the formula A2 minus A1. A2 minus A1 in this case will give me 7 minus 2, and 7 minus 2 is going to give me 5. So in this way we can find out the values of A or A1, A2, A3, D. That is the common difference. Now one more thing that we are supposed to remember. The last term of an AP is denoted by AN. Now suppose, let me just erase these dots over here. And when I erase these dots, what happens is I get an AP which is called as finite AP. Finite AP. See what is the difference between this example 2, 5, 8, 11, 14, 17, 20 and so on. This is an infinite AP where we are not going to get the last term because the number of terms in this AP are uncountable. Now if I consider this AP 2, 7, 12, 17, 22 and if I don't place dots at the end. So such type of AP is called as finite AP. Finite AP means the number of terms in this case are countable. So in this case we'll get the last term. So this 22 can be called as the last term. And you can see here the last term is denoted by AN. So we can say that AN in the above example is equal to 22. So AN is 22 because the last term is 22. In this case, that is this example, we are never going to get the last term because this will move on and on. 23, 26, 29 and so on. Whereas in this AP 2, 7, 12, 17, 22, in this example we will get the last term and the last term will be 22. Now what does this N stands for? Now this N, if I talk only about N, this N stands for number of terms. This N stands for number of terms. So you can count how many terms are there. 1, 2, 3, 4, 5. So we can say that N is equal to 5. That is, the number of terms are 5. So we had so many different terms, like we had A stands for the first term, A2, A3, A4, second term, third term, fourth term and so on. D is the common difference which is given by A2 minus A1. N stands for number of terms and AN is called as the last term.